Of course, in any code base, bugs are inevitable. So how should you approach fixing bugs? Well, we've said this before, but you're not able to fix bugs without a test. And so the first step is to deal with the report of a bug. This could be from a customer. This could be from an automated tool. But once a bug comes in, we need to reproduce or reclassify it. And this is probably one of the hardest steps, especially about bugs that come in from customers. A bug report that says, this thing ain't working is not super helpful until you can figure out exactly what went wrong for the thing to not be working correctly. Importantly, you should always consider that reclassifying a bug is an option. It might not be a bug. It might really be hey, this thing is actually a feature enhancement request. The product works as intended, but the customer's use cases have changed. And so how you do that really helps you figure out in your development cycle how you're going to approach fixing this, right? If it turns out that this bug is an enhancement request, then you would want to prioritize that differently. If it is in fact a bug, you need a regression test. And what is a regression test? A regression test will allow us to ensure that we see the results of a test failing before we fix the test case so that we can be sure that we're actually testing the right thing. Once we see a failing regression test, we can repair the bug. And once we see that regression test passing after our repair, we can release the fix. So that's pushing it to GitHub, deploying it hopefully. And this step should hopefully work for just about any kind of bug. Even in non-agile organizations, you have some variant of this. You might not classify the stories or point them the same way, but it's really impossible to fix a bug unless you understand exactly what caused the bug, how to reproduce it, and how to write a test case which is going to demonstrate the bug. And of course, our agile processes will help fix this. So reporting a bug. The report of a bug usually involves turning some external report into something that gets into our tracking system, whether that's Pivotal Tracker, GitHub Issues, whatever it might be. In the purest form of Agile that we're practicing, a bug counts as 0 points against your story tracking, against your velocity. That doesn't mean bugs are zero effort to fix, quite the contrary. But the reasoning for this is that if it is truly a bug, you don't get credit for releasing the code in terms of velocity and for fixing the code later on, right? If you made a 3-point story and then you got another 3 points for fixing a bug, assuming that you're tracking velocity as a metric of progress and delivering your app, well, that sort of double counts the work because ideally stories should go out without bugs. This is just a reminder that if we're counting bugs as 0-point stories, the velocity that we see from a numerical perspective is again not exactly 100% the work that you did in that iteration, but it's about the feature delivery. Along the way, hopefully you have GitHub automations turned on, whether this is for Track or GitHub Issues, that as you do things like check out a branch, open a pull request, merge that pull request, you can at least save some effort and manual review by leveraging automations to keep the story moving along in the right places. We don't typically enforce this in the class for CHIPS assignments, but if you are using Pivotal Tracker or GitHub Issues, you can automatically start stories as being opened or stories as being started by using particular branch names. And when that branch name arrives on GitHub, it'll show the story as being started. You can also perhaps use more full-featured bug tracking software. So Bugzilla is a popular open source version. And dedicated bug tracking software is useful in terms of prioritizing work that are bugs, but also will help you do things like collect actual feedback. If it's an application that delivers something like crash reports, you might get additional automated logs to deal with those issues. And they're usually another tool where you triage the bugs in a bug tracker, then turn them into stories that you work on a tool like Tracker. But the goal here is before you add too many tools, you should use the simplest tools and process that work for your team. There's no point in adding a fully featured bug tracking tool if all it's going to cause you to do is shuffle and copy and paste comments back and forth between two different websites. Use the tools and process that you need. How do we know whether we reclassify or that we should reproduce and repair. It's always possible to determine that a bug is not a bug or it won't be fixed. Some bugs just don't get fixed because of time priorities, even if they're not necessarily what was intended. The fix could be too hard or could break some other features. It's quite often, right, that you might get a bug report in a complicated application where the fix to that bug would introduce downstream changes depending on the request. So it's perfectly okay to say that some bugs won't be fixed as long as you communicate why, and also let the customer know if it's a customer complaint about what went wrong. Perhaps the hardest part of the bug, once you decide it is a bug, is the steps of reproduction with a simplest possible case. This is hard because in a complicated system, it's often not clear, right, where in our stack something might go wrong. And it really is the case that over the course of a career, you will see things go wrong at all levels of the stack. You will see at some point an interaction perhaps with an OS level library and a Ruby system call that returns some value that you didn't expect. Of course, you'll see simple errors in your highest level JavaScript code or some CSS classes that make something look funny. But reproducing it at the simplest possible case will let you isolate exactly what's going wrong. Once you have a reproduction, you want to then do things like set up an RSpec case or potentially a new set of Cucumber steps that show in the current application something failing. And this usually involves setting up the world such that you can guarantee perhaps that a particular case is guaranteed to happen in our steps. I think the nastiest bugs, for which there are many tales of that exist online, are bugs that relate to dates and times, right? Something only happens on a leap day, or depending on your application, there are leap seconds which get inserted into system clocks where literally time jumps by 1 second. Most apps are not going to be affected by this. But this is a case, right, where you might need to do something like stub the system clock to using timecop to detect a bug. Once you've set up the world, hopefully that test case you see it failing, then you start to work on the repair step. So the test fails. In the presence of the bug there, you fix your code, and then you should see the test case pass. And it's really important that you see that test case fail, because if you haven't guaranteed that the test case fails in the presence of the bug, you don't actually prove that you fixed the bug. Another way of saying this is that if you don't know why something that was broken started working, you can't articulate exactly what changed, you don't actually guarantee that you fixed the problem. It may have temporarily gone away, but you haven't fixed it. That doesn't give you sort of the peace of mind that you would want to continue. What is releasing? Again, that depends on team, but typically pushing this feature to a staging environment, deploying it to production, hopefully is there.